Alright, Chapter 4. We'll be talking about network access. So this is getting into the network. Media. So we have a few types of connections. Home router. These are the wireless or the wired. These are the ones we're most commonly going to see. There are also fiber, but that's a subset of wired. Your router at home can do both. Usually in the commercial, they'll have specific functions. So you have the option to either do wired or wireless. There's also these wonderful range extenders that you can use in order to basically repeat the wireless signal. They're great for if you have a larger house and you don't want to have your router based on one side of the house due to where it comes in. Connected is always better because it's usually almost always faster and you don't have to worry about interference. But you do what you have to do. So, physical layer, that's the actual connection. It's not just physically connected, but the Wi-Fi parts as well. The signal part of Wi-Fi counts as physical layer. So as I said, there's three main types: copper, fiber, and wireless. You see microwave signals, which is really no different than your radio on your TV, on your car, or anything else like that. Fiber, speed of light, and copper, which is speed of electricity. And you have either digital or analog. So, physical standards. They're set by these guys. And they're halfway into the data link layer. Again, we'll talk about that. These grew largely out of the phone physical standards and radio physical standards from way back when. So they will sound familiar, and they will go through the same people that maintain their standards as well. So it makes things easier to understand. Oops. Pull this over here out of the way. Okay, so coding. Modeling wave carrier signal, this is what you get. Amplitude, frequency. These are two different ones. You've heard FM radio and AM radio. This is what they're talking about. Go ahead and read that a little bit here and you'll understand a little more about it, what it is. Data for Wi-Fi is lows and highs, lows and highs. It's not the middle ground of zero. It's all the way at the bottom of the curve, at the top of the curve. It has to hit this point. So when you get interference, it's when this curve isn't going all the way to the top. So only it's halfway up, it doesn't hit the 0, or hit the 1, or halfway down. So it interferes with the way it works. Bandwidth is this amount of traffic. It's not the speed. You always use the word speed, but the word speed is incorrect. It's always the same speed. It's always the speed of light, or the speed of electricity, or the speed of Wi-Fi. It's how much data is sent at the same time. It's like going on the highway. Every car is going 55 miles an hour. Bandwidth is how many lanes do you have? Do you have one lane highway with 55 miles an hour, or do you have 6-lane highway with 55 miles an hour? That's what we're talking about. And we have the abbreviations: megabits, gigabits, terabytes. You'll see these, MB and GB. GB is what they're pushing into nowadays. Cool. Throughput is different than bandwidth. There's always some sort of overhead when you're sending. You're always fighting for amount with other people in your apartment or other people in your office. So throughput is how much is actually going through. Based off the slowness of maybe the router or switch is plugged into, maybe it's really old and you can't handle it, so on and so forth. This is the actual functional result of what you have. So this is basically a back end of a Cisco switch. Fast Ethernet, management ports, and these are the gigabits. These are the big ones that are usually bigger than these. These are usually like 100 megabits. These would be a full gig. The reason being is you have a lot more than this. So you have 9, the full speed would be 9 gigabits, and no, 0.9 gigabits. So basically be able to handle it. Plus, it has overhead parts, so we can talk about TubeCrypt, remember that. Of course, nowadays we're moving 2 gigabits over here and 10 gigs over here, so yay. terminology. These are important to know the differences. Characteristics of copper cabling. That's what I'm talking about, an interference signal. So it doesn't come across as a smooth, hard, it becomes a little different. So what the computer ends up reading is the wrong results. A bit got changed because it didn't get up there. Or it went up and then went back down. Yeah, I know. It's really bad with Wi-Fi. Less so with copper, and almost unheard of with light because there's nothing to bleed in there. It's just light. This one's really weird for that. This is also called crosstalk. So if you have two signals next to each other, they're interfering. EMI is a general concept of like light, of electrical storm, lights, power. Crosstalk is specifically other cable lines. So I need to have a little space between them. So we have the twists in the copper. See these twists here to help get rid of that crosstalk. Whereas copper has three main types: on twist, shielded twisted pair, and coax. Coax is what you see in the back of your TV pretty much. That's your old cable stuff back in the day. We still use it. Why? It's prevalent everywhere. It works pretty good, actually. Unshielded is what you're going to see in a commercial or industrial environment. This is like category 5E or category 6 cables you use. Shielded we don't use much in the United States. That's used when you expect EMI of some kind and you just can't get around it. It's way more expensive than this one. That's why everybody uses this. You have to be careful about running cables because you just don't want to spend the money on this. Other countries make use of it a little more often because it's supposedly better standard. Outer jacket. The cable on the outside protects from damage. It's actually pretty tough. Twisted pair, that prevents crosstalk and interference. And then color coded so you know what lines are which because the pairs matter. Twisted pair have the extra braided foil to keep outside interference. And then they have shielding across the twisted pair to provide even more protection. Oh my goodness, a little extra, huh? Let's go back. Let's take a look here. Yeah, they see cut back on that. So, yeah. Coax. Outer jacket, braided copper protection, insulation, and the main conductor on the little side. Very small. B and C connector, N-type, F-type. N-type is smaller than the F-type. Basically, screw onto, this is the same thing, just smaller. B and C is what's most common nowadays. You'll see for a lot. This is what you see in your cable stuff. Sorry, F-type is what you see in your cable. N-type you don't see too often. This, believe it's smaller. B and C is what you see in a lot of military stuff and a lot of audio, Wi-Fi things, like bigger industrial, commercial size stuff, because you can attach and detach real quickly. It is a little bit weaker. It can have connection problems. So connect properly wired, safety codes, inspect for damage, and make sure you turn the equipment off, make sure you ground it. This is conductive. Fortunately, it's not strongly conductive, so if you do shock yourself, you probably burn yourself out, but you're still going to get that initial shock. I felt it. It hurts like you wouldn't believe. These things can also burn. Again, conductive. The upside is they're very poorly conductive, so a whole lot of energy going through them burns them out, fortunately. Yay. That's something you want to test. So you have to be aware somewhat. Safety is mostly worried about the damage you might inflict on the components rather than any damage to you, but you still have to worry about that. And you still definitely have to worry about damage to your equipment. Again, try this out. Okay, we're in here to our first stopping point. UTP. Twists cancel each other. Varying number of twists per one. See, a little more twists, less twists. This matters. There is a set coloring scheme for your RJ45 connectors. We'll talk about that. Category 3 was straight tip. Mostly voice, don't even see them too often anymore. Category 5. Sports 100 megabit can do full gig if you do it right. Cat 5e does a full gig. Now Cat 6 was coming out here. It supports 100 full gig to 10 gigs if you do it right. Not recommended. It will wear it out. These do better distances. Do better over distances as well. They're coming out with more later on, of course. RJ45s. These are the plugs. They look like RJ11s. Your phone ones. These separate. As I said, Ethernet grew out of phones, so this is a bigger version. Color codings matter. Again, these are the sockets you plug into. You might see them on your wall, you might see them at your business. Put out the end of cables, so on and so forth. Back connector, all the way in. Look us over. I can't have you practice it, unfortunately, like you guys have here, but it's important you know this. There are two standards, A and B. The difference between A and B is green and orange. I have these memorized. The kids are here are memorizing them. This is important because you will do, if you do this as an industry, you will do a lot of tipping. As we said, the number of twists matter. So even if you do this at home, you want to do this so that you actually get the proper signal. I've seen people not do it right. It causes problems. Straight through, both sides are the same. A on one side, A on the other. Crossover, A on one side, B on the other. Rollover is a Cisco proprietary cable used to connect workstation to router or switch console port. It's a special cable we have. They also use it for what they call their, whatever. These are the only two you really need. Rollover you'll see on the test. Just make sure you know for the test. In real life you'll never hear me talk about it. These are what you need to know. And what the difference is. Testing. We have a tester. You guys won't be able to use it. Sorry. So, here's your be able to check A and B. Yay. Do it. Learn it. It's important. Oop. Did I go too far? We don't have any homework for you on this one. You might want to go through and look at this and just kind of write down the steps, because as I said, I can't have you do it because I don't have you here. But it's in the word. So I'm going to stop. Right now, I want to go through the whole thing here. I can't yet. I've got 3 more minutes. Let's see how far I can get. Fiber. Faster. Way faster. Submarines, long haul. This is stuff we use between cities. But you have to have boosters too. Jacket, strength of material to protect from damage, buffer, cladding, core. It's actually a very, very tiny part where all the light is sent to it. You have single mode, that's one beam of light. Multi-mode, multiple beams of light. Multi-mode, faster, shorter range. Slower, longer range. Go ahead and read through this. It's important to know the differences. LEDs are the cheaper version. Again, not good range. Lasers, better range. So you tend to have single laser and light LEDs and short range fiber. You gotta know what you're working with. Different types of connectors. I think we are on the duplex. These are older ones, I think, and then these are the two main ones, if I remember correctly. Again, double check. Yeah. You'll see orange and yellow. They're supposed to, yeah, whatever. Again, tester. It needs different testing equipment. We don't have any here because we don't work with it. Again, it tells you the differences. Copper's weight is cheaper. That's a big advantage. It's slower. It's more prone to interference. But it's cheaper. Way, way cheaper. So that's why you see it in buildings, not outside. Try it. Do the activity. Wireless. Oh, yes. Wireless is fun. We all use it. We all need it. Why? Because it's easy to set up. Everybody has wireless at home. I'd be surprised if you don't. You get good range, about 300 feet. Problem is, you have interference with electrical, with thunderstorms, so on and so forth. Again, security, everybody can see it pretty much, unless you configure it certain ways. And it's half duplex, which means you have to share, well, it sounds like a half duplex, but you have to share. So if there's 5 devices on there, you're sharing the whole bandwidth of 5 devices. Standards for different types. Bluetooth is short range, like your headsets. WiMAX is citywide. Wi-Fi is what you're used to. Access point is like your router at home, except for only does Wi-Fi, it plugs into a bigger wireless at home. NIC adapters, yeah, we probably have them. Your laptop has built in, but you can put them on the back of your PC. Do this one. This is your homework assignment. I'll walk you through it next time. Yep. There you go. We'll leave it out here and I'll do the rest.